Hey everyone, so we're back doing another theorem called Proportionality Theorem, and you may be wondering why I am doing it again, but this time I'm going to do it a little bit differently. So this time what we're required to prove will be that we divide AD by AB, and that is equal to AE divided by AC. So let's see how it goes. So we still have the same statement of the theorem. If a line parallel to one side of a triangle intersects the other two sides of the triangle, then the line divides these two sides proportionally. So we still have the same diagram. The diagram will name A, B, and C, the triangle. Then we'll have D on AB and have E on AC, so that we draw a line parallel to BC, the third side. And then what the theorem says is that the two pieces that we have will be in proportion. Okay, so but now what we're required to prove is that AD divided by the whole of AB equals AE divided by the whole of AC, as I said. Okay, so proof, we join B to E and then D to C. Then we see that we have created triangles. First, I need you to concentrate on the blue highlighted triangles. We have the big one ABE and the small one ADE that we're going to be looking at. We're also going to be using this one later on, but for now, the first part of the theorem, we're going to be concentrating on the big triangle and ADE. So as you can see, all of these triangles that are blue, if we take this AD to be the base of ADE and the whole of AB to be the base of ABE, and even if we wanted to use this one here, we could take this one to be the base, and for all these three triangles, H1 drawn from here perpendicular to here to E will be the height of all these blue triangles. Okay, so when I write H1 next, I'll use blue so that you remember it's related to the blue triangles. Next, on the other side, we have these red triangles. The same reasoning, same way I explained, we're going to use ADE and the whole of ADC or ACD. So we're going to use them, and then for them, if we choose this side to be the basis, the height will be drawn again from that base perpendicular until D, up to D. Okay, now we start by saying the area of triangle ADE divided by the area of triangle ABE, we get half this triangle here and this triangle, the big one here. So we get half of AD divided by multiplied by H1 divided by half AB multiplied by H1 as well. And the H1s will cancel, the halves will cancel. Then we'll be remaining with AD over AB. This is because they have the same height. We just mentioned that before. Okay, next, the red triangles that we highlighted before. ADE again, and the big one. So it's this ADE and the big one ADC or ACD. Then for these two, we'll also have half AE divided by multiplied by H2 and half AC multiplied by H2. Then again, this simplifies to be AE over AC, and the same reason of have them all having the red height, same height. Next, what we want to do is we want to end up equating these two things. But we first need to prove that since, yes, we see the numerators are the same, it's the same triangle ADE, we now need to prove that ABE's area and ACD's area are the same. But let's look at ABE. ABE is actually made up of triangle ADE and this triangle DBE, this one here. And then on the right side, we also have the same situation. The big triangle ACD is actually made up of ADE and this ECD. So in order for these two to be equal, it means we must show that this right hand side is also equal. So far this is the same thing. We just need to prove that these two are equal as well. So what we'll do is we'll highlight the two triangles, and then you'll see that these two triangles are within the same parallel lines, which means they'll have the same height if we choose DE as the base. And we choose DE as the base for both of them. So it means they will exactly have the same area, half DE, and the same height. So which means they are equal. They have the same base and the same height. So if we choose BE as the base, it will be the same base for both two triangles, and they will have the same height since they're in parallel lines. So now it means, since we have proved that these two are equal, it means here we're adding the same things on the right hand side, because this is equal to this and this is the same thing as this. This concludes our proof of these two being equal. So which means we can now say that ABE is the same as ACD, the areas. So now it means we have showed that these two fractions are the same. This one is equal to this one, because we needed to show only these two to be equal. Now since these two each equal these ratios here, it means we can now conclude and say AD over AB is the same as AE over AC. And that's the proof. Thank you very much. Like and subscribe and share this video. Leave comments in the comment section to suggest new videos that I should do. I'll see you in the next one. Bye. Again, in GeoGebra we can see that the property still holds. So again, it's a little bit different here. We have AD and AB over here instead of DB. So it's 5 point something here, 5.52 divided by the whole of this, which is 9.71. Same goes for the other side, and it doesn't matter what the shape is, the ratio remains the same. Even if I keep A on one place and then move this one, we have the same ratio still, with the length of AC and AE changing. And if I move this one, it's the blue side that changes, but the ratio remain equal. And we can move the line DE, and we see that AC and AD are not changing. What's changing is AC and AB are not changing. What's changing is the top AD and AE, but the ratios on the end remain equal still, no matter where I put the line DE. think I've played with this long enough and you get what's going on. So like and subscribe and make suggestions.